Hello, ladies and gentlemen. Welcome to today's video. Today, we will focus on chemistry, reactivity of metals. In this chapter, we will master a few techniques. First, the reactivity series. This one, you need to know the sequence. And from the sequence, you should know whether it will react with water, steam, acids, and also how the displacement happen. And then there is one special situation called aluminium oxide. The second thing that we need to go is corrosion. So we know that the cause of corrosion and how to prevent it. There are two ways to prevent it. First, chemistry student, we must know how sacrificial production happens. And then the most famous name called galvanizing is referred to which metal. You need to know that. And then barrier method is the very easy technique that we already learned that from primary. Last, we go to the extraction. We only need to know two types of extraction, which is iron and aluminium. So let's go one by one. First of all, we need to remember from potassium, sodium to gold. So first thing that you need to know is potassium and sodium is very reactive. So please stand is potassium, sodium. These two belongs to group 1, very reactive. And then cat, monkey, and zebra into cute size garden. Calcium, magnesium, aluminium, zinc, and iron, and copper, silver, gold. So after we know this, we need to know two more positions for two very famous non-metal. First non-metal is here, which is hydrogen. So hydrogen is above these three, which is copper, silver, gold. So copper, silver, gold is very, very not reactive because things that have hydrogen, they will not react at all. And then the second thing is carbon. Carbon is between A to Z. A to Z, in between have a carbon here. So after we know these two, so let's go for the two application. First is about the reactivity with cold water, steam, and acid. Water and steam is the same thing, just steam is the hot water that is in vapor state, and then acid is H+, agree or not? So this we already learned in acid and base chapter. So if you need this information, you can go back to my previous video. Okay, these three of them, copper, silver, and gold, they are below the hydrogen. So no matter it's water, steam, and acid, they will not have reaction at all. And then for cold water, because of the temperature is very low, so only the very reactive group 1 metals can react vigorously. All of these, they will react, but will react slowly. For example, iron, if we put cold water, it won't show you immediate rusting. It will take time to rust. So that's why for all water, especially the cold one, we will obviously see these two, but other you still have reaction, but slow. And then hot steam or acid, them will react, but of course the reactivity will reduce when going down the group. Okay, second thing that we need to know is displacement. Displacement is when a metal, for example, magnesium, it meets with another metal that is in ion state, which is ionic bond initially. Two of them will compare with each other. Who is more reactive? Obviously, magnesium is more reactive. So the one that more reactive prefer to be in iron, which initially is not iron, but zinc is in iron. So after they confirm with each other, magnesium prefer to become iron. That's why magnesium will involve in the ionic bond to form magnesium chloride. While zinc that is not that reactive will go back to metal. So in this situation, displacement happens. How about reversely, we use magnesium chloride, zinc, we put them together. So they will ask each other, magnesium prefer to become iron. So magnesium already in iron and he happy in this state. Zinc is less reactive, he prefer in atom itself. So no displacement happen. Okay, so in reactivity series, the third thing that we need to know is about aluminium is very special. Aluminium, even though the reactivity is quite high compared to this, but aluminium, after it forms one layer of oxide, which is aluminium oxides, then any reaction will stop there because aluminium oxides is a unreactive layer, which means it will stop all the reactivity after this. So let's see the first question, reactivity series, and give you this, ask you what is X and Y. So according to, please send cat, monkey, and zebra into cute small garden. So we know potassium is here, calcium is here, aluminium is here. So obviously X is sodium. Y is magnesium. So that's why you need to remember the series. Next, they say silver is below copper. Which row describe the reaction of silver? So we know that copper, silver, and gold do not react with steam, do not react with HCl because the position of hydrogen is above them. So three of them not reactive compared to hydrogen. So no reaction, no reaction. Next, three students X, Y, Z are told that solid P react with acid and also conduct electricity. So it's confirmed not copper because copper won't react with acid. Graphite also won't react with acid because only the metals here can react with acids. So we can confirm the answer is just Y. Next, four metal QRST are each added to separate samples of water, steam, and dilute HCl. So we know that the thing that no reaction with water is less reactive, and then this one continue to no reaction with steam, so we can confirm R is very, very not reactive. And then, of course, S is slightly more reactive than it. Then we continue to see Q and T. Q is slow reaction, so that's why it's not that reactive, but confirm more reactive than these two. And then the fast reaction is T. Then we can confirm like this. So they say R is the least reactive metal. Yes. They say T could be potassium. So fast reaction, explode, explode. Yes. Group 1 situation. S is more reactive than Q and R. No. S is more reactive than R, but less reactive than Q. 4. Metals generally react faster in steam compared to water. So steam is the high temperature situation. Water is lower temperature. So yes. So answer is A. Next, I give you description. Calcium react with cold water. So that's why it's quite high. Lead reacts slowly when heated in air. So it's slightly above the last three, Pb. Silver do not react in air or water, so silver is below it. Zinc react when heated with steam to produce hydrogen. We compare these two, we know that lead, no reaction with steam, but zinc heated with steam to produce hydrogen, so zinc is slightly more reactive than Pb. So in the syllabus, they do not ask you to remember where's the position of lead and also tin, but they will hint you if they ask about this. So that's why you can see from the relationship, we know that Pb is slightly lower than zinc. So the least reactive is silver, then it's lead, zinc, and calcium. If you are interested to position of lead and tin, after iron is tin, then lead, then only to copper. They do not need you to memorize these two. It's not stated in the syllabus. Next, it says iron nail is added to copper sulfate and magnesium sulfate. So we know that iron is here, copper is here, magnesium is here. So iron is more reactive than copper, less reactive than magnesium. So that's why displacement happen, displacement not happen. Iron, it prefer to become iron 3+, which means iron is oxidized easily. So iron is oxidized more easily compared to copper. Next question, a student added a sample of a metal to aqueous metal salts and see whether displacement happened. They put magnesium into iron. Magnesium is more reactive. Yes, that's why they will have displacement. So initially we have Fe2 plus green in color. So after the reaction, magnesium is group 2 based on periodic table, no color, because only transition element can have colored ion. If you need this information, you can refer back to my previous video about periodic table. Next, silver and copper. Copper is ion, so nothing will change. So copper ion initially is in blue color, at last is still blue color. So next question gives us the information about lead, manganese, silver, and zinc. We do not memorize lead and manganese. So we need to see from this situation. So we know that zinc, manganese, and lead, all they can displace silver. Means that silver don't like to be iron. So that's why no matter who comes, he will say, okay, let you guys become iron. I will go back to atom. Silver is the least reactive, so that's why they will never have reaction with all three of them. Then next information can see from this and this. So lead and manganese unable to displace zinc nitride means that zinc prefer to become iron compared to lead and manganese. So zinc for sure can displace two of them because zinc is more reactive. So last information, we need to compare lead and manganese. Manganese can displace lead. So we can confirm manganese is more reactive than lead. So lead cannot displace manganese. Then we know the relationship. Zinc is most reactive, silver is least reactive. So they ask us to complete table 3.1 and place the four metals in their order of reactivity. So they do not mention its name or what, so we can write in symbol also. Zinc, manganese, lead, silver. Next, let's go to corrosion of iron. We know that iron will form rust because it contact with oxygen and water and form hydrated iron 3 oxides. So hydrated means it contains water. Iron 3 is iron become 2 plus. At last, it forms 3 plus. So it's the final oxidized state. So when iron get oxidized by oxygen and water, it will form Fe2O3. So this is iron 3 oxides and hydrated state. The chemical name of rust is hydrated iron 3 oxides. So how to prevent this? First method called sacrificial protection. We have something that can protect iron because they are more reactive than iron, so they will oxidize instead of iron. They will lose electron and become positive ion, so they will oxidize. Iron will not get oxidized. That's why iron is safe from rusting. The very famous situation, we call them galvanizing, which we use zinc to put together with iron, so zinc will protect iron from rusting. This method, we call them galvanizing. The second technique that we can use is barrier method. We can paint it, we can grease it, we can coat it with plastic, or even we can coat it with less reactive coating. Anything that can prevent iron from contact with oxygen and water, we call them barrier method. Let's see the first question. Preventing the rusting of steel is important. State the chemical name of rust. So it's hydrated iron 3 oxides. Next, metal X act as sacrificial metal, means that it's more reactive than iron. Metal X do not act as sacrificial metal to prevent aluminium from corroding. So it will be in between aluminium and iron. According to, please send cat, monkey, and zebra into cute small garden. It's in between aluminium and iron. Obviously zinc. Next, iron rust when it contact with water and oxygen. Magnesium block attached to the bottom of steel boat. The magnesium does not completely cover. They do not need to completely cover because they are more reactive. They will oxidize more readily. That's why even though they do not form the barrier layer, they can still protect iron and steel from rusting. The magnesium block provide sacrificial protection. Explain in terms of electron. We know all metal, they will form cation, positive ion, so they will lose electron. So the more reactive, they will lose electron more readily. Magnesium is more reactive. It will lose electron more readily than iron. Next, name a metal that cannot provide sacrificial protection. Sacrificial protection must use something that is more reactive. So anything that below iron, we can use it. For example, copper. Of course, you can say silver or gold, and then make sure it's a name. Don't write Cu. They are not asking for symbol. Next, block of magnesium are attached to the bottom of steel wood to prevent rusting. Which equation describes change that prevents steel from rusting? Because magnesium is more reactive, so it's more readily to form Mg2 plus by releasing the electron. So answer is D. Next, steel can be coated with zinc to prevent rusting. This provides both a barrier method if it's fully covered and sacrificial protection because it's more reactive. So state the term used for coating steel with zinc, galvanizing. Next, describe another barrier method for prevent rusting. We can paint it or we can coat it with plastic. Explain how zinc provides sacrificial protection. Zinc is more reactive, so it will oxidize more readily than iron. Next, which coating prevents iron from rusting even the coating is damaged? This is obviously something sacrificial protection. Even we do not completely cover it, it still can have the protection, so it's zinc. Next, rusting is prevented by coating iron with zinc. Name the substance that reacts with iron to form rust, oxygen and water. Must state both because both presence then rusting can happen. Next, name the process in which zinc is used to coat iron to prevent rusting. It's the same, galvanizing. Explain how the coating of zinc prevents rusting if the zinc is not scratched. So if it's not scratched, then it's actually a barrier method. And it prevents oxygen and water reaching the iron. When zinc is scratched and iron become exposed, explain how zinc continue to prevent rusting. It's again the same. Zinc is more reactive and then it will oxidize more readily than iron, just like that. So next, go to the extraction of metals. We'll go for iron first. So iron itself, in the ore state, we call them hematite. Other than hematite, we also need to add coke. Coke itself is actually the carbon. The coke can release heat because it helps to burn, and also it can reduce iron trioxides. Because we want to make iron trioxides back to pure iron metal. So coke can reduce iron trioxide to pure iron. Last is it can react with CO2 to form carbon monoxide. So carbon monoxide is very effective to help reducing iron trioxide. These are the three functions of coke. Next, we also add limestone. Limestone itself is CaCO3 calcium carbonate. So when it's in high temperatures, it will have thermal decomposition. It will decompose, it will break down to CaO, and then the balance CO2 will release at carbon dioxide. After we form calcium oxides, these calcium oxides can react with impurities, which is silicon oxides. When they combine together, it will form Ca1, Si1, or we have three. You do not need to memorize, we just sum them together. This thing called slag. So we can remove the impurities of silicon 4 oxides, and then we can have a pure iron. So this is everything about the extraction of iron. Second extraction, aluminium. So aluminium or bauxite. This thing is more reactive than carbon, so that's why we cannot use carbon, we cannot use coke to extract it. We must use electrolysis. So if you're not very sure how to do electrolysis, you can refer back to my previous electrolysis video. At cathode, the aluminium 3+ will gain electron to form aluminium pure metal. That's why aluminium pure metal will flow down. And then at the anode side, there will discharge oxide O2- to form oxygen and release 4 electrons. Because of the release of oxygen, the oxygen can react with carbon to form CO2. So that's why our anode that is made from the graphite is actually a carbon. They need to continuously to replace because it will become thinner and thinner because carbon will react with oxygen. Next, other than we put bauxite in the electrolysis, we also put one more thing called cryolite. Cryolite is actually a substance that can lower the operating temperature. Without cryolite, we need to melt bauxite in a very, very, very high temperature. If we put cryolite inside, then the temperature can reduce. So this is the first reason we add cryolite. Second reason, it can also improve the conductivity because we need to do electrolysis. So the conductivity is very important. So cryolite can improve the conductivity. So this is everything that we need to know about extraction of aluminium. Then let's go to the IG's question. First question that says metal M is between sodium and magnesium in the reactivity series. Sodium is here, magnesium is here. The metal that's in between them is calcium. Which reaction occurs with M and its oxides? So M, can it react with steam? Of course, yes. M, can it extract by heating it with carbon? Carbon is in between A to Z. So everything above carbon, we cannot use carbon or coke to extract it. We must use electrolysis. So answer is C. Next, Which equation represent the reduction of compound found in hematite? So hematite, we have this. We add carbon or CO. At last, it will form Fe. So this is the reduction. So we have Fe here, Fe2O3. So answer is just donkey. Next, the list gives the order of some metals and hydrogen in the reactivity series. Metal X is also included. Metal X is below hydrogen, so which show represent the properties of metal X. React with dilute acid? No. Below hydrogen, it cannot react with acid. And can it reduce by carbon? Yes. Because in between A to Z is carbon, anything below can reduce by carbon. So answer is B. Next, name the main ore of iron used in blast furnace is hematite. Name the substance that enter the blast furnace at A is hot air, or you can just write air. Name the reducing agent in the extraction of iron. Who will reduce iron trioxides? Carbon monoxide is the main thing. Remember its name, so don't write CO, you must write carbon monoxide. Explain why limestone is added to the blast furnace. You need to give the details. 3-mark question. First point, limestone undergo decomposition and then it will form calcium oxide. It will react with silicon oxide and form slag. Next, coke and iron ore are added at the top of the blast furnace. Name other substance that added together. So it's limestone. Or of course, you can write calcium carbonate also. And then name the substance that leaves blast furnace at A. The most bottom part is highest density part, which is molten iron, or you can just write iron. Slag is produced from impurity in iron ore. Name the impurity. So it's silicon oxide. And then name 2 substances that react together to produce high temperature. Who will cause high temperature is coke and oxygen when they burn. 5. Name 2 waste gases that leave the blast furnace. So include carbon dioxide. And you can say it's nitrogen. That's all. Next, give 2 reasons why coke is added into the blast furnace. Just now we already said it releases heat. And second, it reduces iron trioxide. This is the main reason of adding coke. Of course, you can say it will react with carbon dioxide to form carbon monoxide because carbon monoxide is the main reducing agent. Number 2, explain how limestone removes impurities. Limestone undergo thermal decomposition. Calcium oxide react with silicon oxide to form slag. It's the same thing that you need to say. 3. Hematite contains iron trioxides. Write a simple equation for the conversion of iron trioxides to iron in blast furnace. Iron trioxides is Fe2O3. You can use carbon, you can use carbon monoxide, but carbon is easier to do balancing, so that's why I prefer to use carbon. We have 2 Fe done. Since here already fixed, so here 3 oxygen also fixed already. So here I put 3/2. So here oxygen also have 3. And then here 3/2 carbon, here also 3/2 carbon. After balancing, we know that we cannot have any fraction. To remove denominator, we times everything with 2. So at last is 2, 3, 4, 3. Of course, they will accept if you use iron trioxides react with carbon monoxide to form Fe and CO2. And then you need to balance 3, 2, 3. Like this is also okay. Next, suggest why the iron produced in the blast furnace is molten, because temperature in the furnace is higher than melting point iron. Just like that. Next, 4 substances present in blast furnace during iron extraction are listed, which are both reactant and product. Calcium carbonate only reactant. Carbon dioxide, it can react with carbon to form carbon monoxide. So it's reactant and also a product, because when we reduce iron trioxides with carbon or carbon monoxide, it will form CO2. So number 2, yes. Carbon monoxide can form when carbon plus CO2 to form carbon monoxide. So it's actually a product, and carbon monoxide can use to reduce iron trioxide. So it's a reactant. Carbon monoxides also act as both product and reactant. And trioxides, it obviously just reactant. So the answer is 2 and 3. Next, aluminium metal is extracted from its purified ore by electrolysis. Which statement about electrolyte in the process is correct? The electrolyte is purified molten bauxite only. No. Still remember, we also use molten chrolite. Must have molten chrolite. So only molten chrolite is wrong. Molten chrolite dissolve bauxite. No. This chrolite is used to dissolve the bauxite. So answer is B. Next, name the ore of aluminium is bauxite. The electrolyte aluminium oxides and one other substance. Name the other substance and explain why it is used. We add chrolite so that it can lower the operating temperature. Next, write the ionic half equation. Cathode. Cathode here we only have one cation. It will get electron to form aluminium, the pure metal. Explain why the anode needs to frequently replace, because anode itself is carbon, will react with oxygen and form carbon dioxide. That's why we need to frequently replace it. Next, bauxite is an ore containing aluminium. Name the aluminium compound that is in purified bauxite. Is aluminium oxide. State 2 reason chrolite is using. Previous question we already mentioned it lowers the operating temperature. The previous question we mentioned about it can use as solvent. In the front, we also mentioned it can increase the conductivity. So all these three answers accepted. Then the anode is made from carbon. Explain why carbon anode need to replace regularly is same as the previous question, because carbon will react with oxygen and form carbon dioxide, just like this. Okay, it's the end of this chapter. So if you face any problem, please feel free to comment here. And please don't forget to subscribe, like, and share my YouTube channel. Hope you enjoyed the session and see you in the next class. Bye-bye.